Downtime could lead to an erosion of trust, especially when it comes to moving money around. Why don't you get us started with talking about challenge number 2 here?
Yeah, I mean, so it depends on, on downtime of system down. I sort of look at things as unplanned downtime versus downtime, right? Unplanned downtime is your killer because it came in obviously at a point where you didn't anticipate it, and system failures are even worse, right? We're all being held to these standards of these ridiculous 99.9999999% metrics, right? It's like, okay, just make sure you're up all the time. Well, that's probably unrealistic in some of these distributed modules. So, instead we focus on things like how do we do auto failover? How do we do, some of these different, schemes for fallback and rollback? And I think that's really sort of where we see more and more happening going forward is that, if you accept on surface that software failure and errors are going to happen, right? I mean, I think the fallacy that everybody always lives on is like, oh, well, we won't ship software with bugs. It's like, yes, you will. Face it, it's going to happen, right? So these things happen. Then I think you get into some of the conversations around, okay, so now how do I recover fastest? How do I do sort of canary testing and A/B type things so that, maybe I only roll out, a couple of features in a certain node, right? So I know the CloudBees guys are doing a lot of work with feature flags for, how do I turn this on and then turn it off quickly if something goes sideways? So that I don't, upgrade everything in the world. In a lot of respects, the microservices and the promises of some of these distributed systems enable us to do that a lot easier than the monolithic apps that we've dealt with in the past, where it's sort of an all or nothing. But I think the important thing is that, like Anders said, do it at the whiteboard first, guys, right? It's microservices are not going to solve this for you, right? You've got to think about, what is my failover strategy? What's my rollback strategy? How do I think that this is going to get deployed on my nightlies? And how do I want to push out some of these updates on a regular basis? And I think part of what we struggle with as an industry still is there's a lot of, you get to a point where you're ready to deploy and there's a lot of sort of, okay, well, cross your fingers and hope it runs. And that's the model we need to get away from, because that's the model that inevitably causes that downtime. It's you didn't know what's going to happen when it inevitably fails, right? And so I think that's part of what we do at OverOps with some of the continuous reliability that the CloudBees guys do with their continuous deployment strategies. Is we're all about making sure if bad things happen, you can recover quickly, and that it's not an all or nothing proposition, that I can turn features on or off, I can enable or disable, and how do I find and resolve as fast as possible and identify things that are likely to cause problems before those problems occur. I think if we can get better at identifying problems before they happen, recovering from them before a customer noticed, and failing over gracefully when the inevitable happens, I think right there, that's what the industry expects of us as software leaders.
Yeah, and I think, one of the biggest lessons I've learned in that arena comes from the TV show Mythbusters, which is, stated very simply, failure is always an option. And you have to sort of plan for that, right? If you're always planning for the happy path and always planning that, oh, everything's going to work, boy, are you going to be in for a rough time, right? And so I think more and more, part of what microservices allows us to do, or loosely coupled applications and architectures to be a little bit more generic, is to start to separate out all the concerns. And as you referred to, Bob, when you're dealing with a monolithic application, to deploy anything, you have to deploy everything, and that's very painful. And so what a loosely coupled architecture allows us to do is, among other things, is deploy sort of piecemeal. When the service is ready and ready to be updated, we can deploy it, and we can take that even further and tease out and separate, using things like feature flags, the code deployment motion from the turning on the feature motion. And so, because those are two separate things that can cause separate problems, right? I can have a problem when I'm deploying the service where, maybe the service isn't compatible with something, and I don't know that till I push the code out. But if I push the code out and don't turn the feature on, then I'm the only one who's going to notice that. And if I'm doing proper, log monitoring and those sorts of things, I can then pull that back. And especially then if I'm doing blue-green or doing canary patterns or those sorts of things, no customer will likely notice, or a very tiny percentage of customers will notice. And then if I'm then separating out the motion to deploy from the motion to change, database schemas or those sorts of things, from the motion to turn things on and turn things off at the feature level, I now have, I'm putting much less at risk every time I make a change to my environment. It's a lot less like walking into the casino with my pile of money and bet it all on black, right? It's a much more subtle motion than that, where I can incrementally move my way into where I'm going to turn things on. And once I'm confident that the first 5% of the traffic that's going into that new feature seems to be working, so let's turn up the heat to 25% to 50, all the way up. I really have a much more gradual way of turning things on and finding out problems, as opposed to the bad old days, which some of us are still stuck in, where it's all or nothing. And all or nothing is just so painful when things go wrong. So I think the new architectures really matter. The new tooling really matters. The new processes really matter, and the new culture that we're building around it matters as well.
Yeah, I think that's exactly right. I think the other thing that we don't want to lose sight of in here is that there's a whole lot of software that's been written in the world before today, and not everybody can move to these architectures at once. So I think the other important piece here that all of us are trying to work our way through is, how do we get to that phase, right? So how do we help you avoid downtime as people are evolving their architectures from some of these larger monolithics, and they're building things into smaller services? Sometimes people can't help but having those big bang releases. So a lot of this is figuring out, okay, we're going to be stuck with some of that model for a while. Everybody wants to get to nirvana. It doesn't happen overnight. This is true for us here at OverOps. I'm sure it's true at every other company. So it's also a matter of, how do we, as we drive these initiatives throughout our organizations, how do we sort of take advantage of the technology in piecemeal on our way through as well? And so looking at pieces like that across some of the build stack, looking at that with the various tools from, not just ourselves, but our, some of our partners, about, how do we make sure that we've got the most robust infrastructures moving forward, and that also we can recover from them super gracefully when things go badly. I think that's sort of, just, it's table stakes going into the next sort of, several, years of engineering as these, organizations are evolving their tech.
I think that's, that's a great point. And I think it is really important not to lose sight of the fact that most of the world is evolving their technology stack, is evolving their code base, right? It's not one of these things where we have the fortune, where we're fortunate enough to be able to say, turn things off for a year while we refactor our code base, right? We essentially have to be swapping out the engine or swapping out the tires on the car while we're driving 65 miles an hour down the road. And that's a lot more difficult and a lot more challenging than greenfield opportunities. But greenfield opportunities are one thing. The reality is, we have applications, they're deployed, they're operational, they're bringing in money, and we're not going to just be able to, shovel that out and shovel in the new architecture, right? It's going to be much more evolutionary and much more kind of strangler pattern of chipping away at the monolith, or as Mirko Hearing said once at a conference, it's not really chipping away at the monolith, it's eroding the monolith. It can be a very sort of glacial or geological process. And we have to have patience around that, and we have to have tooling accordingly, and understand that you don't just overnight take your large monolithic application and break it into 50 different microservices. Ain't gonna happen. So you have to have the patience to do that iteration and do all of that work that has to be done to modernize that and to do it in a smart way, and to evolve your tooling alongside of it.
Yeah, absolutely.
Great, and I love how you brought up the cultural aspect, because you could have all the tools and the systems and processes in place, but the team really needs to buy into all these changes, and that can certainly take a lot of time. That's a great point. Yeah.
I mean, I think when you look at the broader topic of sort of digital transformations and DevOps transformations, those sorts of things, one of the most troublesome issues that organizations run into is around culture, because it really is it's a mindset. It's a change in how we do things. It's more openness, more transparency, less blame, and more problem solving, and more opportunities for learning. And there's cultures out there where, what the leadership wants is, one throat to choke. And they see that as the way to manage the problem, which, good luck with that, right? So I think it's really good that as an industry, software industry, financial industry, so on, we're really taking a look at that and paying attention to the cultural aspects of this, because, if you read the history of NASA and the accidents that have happened there's some really fascinating and obviously tragic learnings that we've had to repeat several times. And you learn that culture is not the people. Culture is a little bit beyond the people, and that you can't just remove the people and bring in new people and expect that the culture all of a sudden will be healthy and good and different. So it's something that you have to work at explicitly. It's not something that you can just sort of assume will take shape and assume, we'll do CI and CD and the culture will take care of itself. Doesn't happen that way.
Yeah, it's institutional learning that sort of tends to sort of set in. And the other is that a lot of the monolithic apps, Anders, you got a little bit of gray hair. I have gray hair for what's left, right? We've lived through some of this, right? The monolithic apps are actually in a lot of respects easier, right? You control all the pieces.
Where the problem is.
Yeah, and so that institutional knowledge of, hey, we've always done it this way, and it's worked in the past, right? We've been successful to get to this point. That's a hard thing to break for people. The other part that's difficult for people to embrace, and the open source movement really demonstrated this, is getting away from that not invented here syndrome. In order for us to move fast as an industry, in order for us to enable our customers to bring new capabilities to their customers faster, we have to assume that we can't build everything ourselves, right? You can't build this big monolith. So even if you build all of your code perfectly, third-party libraries change, right? Operating systems change. The pieces underneath you rev out, and they rev at paces. I've lived in the data integration space for a number of years, and the one thing that really irritated me was that not every vendor on the planet synced their release schedule with mine. So I'd have an integration tool, and then somebody we integrated with upgraded an API. It would have been simpler if everybody upgraded everything simultaneously, but they don't. So we need to think about all those things in terms of a simple upgrade for one microservice that upgraded a library may have a downstream ripple effect on somebody else. And if your institutional knowledge is still about blame, if it's about how did this happen? How do I test my way around it? You're gonna be failing, right? No matter what. This is why things like CI and CD are important. It's why continuous reliability is important. It's really monitoring every aspect of your system and recovering gracefully as fast as you can. I know that we're calling this avoiding downtime for this slide. You're not going to totally avoid it ever, right? So it's how do you recover from it, and how to institutionally you handle it better. And I think that's the important thing that all of us need to embrace.
Yeah, and it's about resiliency, right? It's about how do you handle when there are failures, and how do you how can you trigger failures in an experimental way? How can you before you go into production, and how do you rapidly diagnose problems once they do happen and address them quickly? Because downtime will happen, right? It's just a fact of life. And I think about it a little bit. You think about how Google has some famous stories about how they run data centers, and in particular the hardware aspects of data centers. When there's a hardware failure, they don't run and go find the disk drive that just failed, right? They built a system that's resilient to that failure, and then once a year they go pick out the dead hardware and throw it out. They don't go, oh, I better go replace that hard drive, it just failed. They built the software to anticipate the hardware failure, and that way the hardware is going to fail. There's just a certain failure rate that you're going to expect at that scale. And any system that's going to be built around finding the failing drive and replacing it quickly is bound to fail. And I think we have to think about software a little bit that way as we go forward, in terms of failures will happen. Network cables will be tripped over. Power cables will be tripped over. Circuit breakers will break, right? I mean, we just have to anticipate these things and understand that they will happen, and have a little bit of sort of foresight into, okay, what about when that breaks? What about then when that breaks? What about when that breaks? And really have a plan for what we're going to do when that happens. Because, you know, you don't want to be shocked by that at 2 a.m, right? And not have thought about it, not have anticipated it, because then it's a very stressful situation. You may even make things worse, right? So it's very much a sort of rehearse, figure out, plan what your potential outages are, and of course you're not going to think of everything, right? I mean, that's a given. But the more you think about what the failure modes are, the more you're going to be ready to handle them, you know, in as quick fashion as possible, you know, on game day, essentially, when the problem occurs.